Hello everyone, I welcome you all in today's lecture. In previous lecture we have discussed about the parallel line method of development, which is mainly used for the development of prism or cylinder. Okay, in today's lecture we'll go through the some of the problem which are the based on parallel line method. So first problem is there. Produce the pattern for the pentagonal duct as shown in the figure. We have given a pentagonal duct. This is the front view of the duct and this is the top view of the duct. Okay, so we can see that a pentagonal prism have been truncated from the top and as well as from the bottom, and there is one pipe hole is given on one surface of the pentagonal prism. Okay, so first of all we will start by naming it. So 1 2 3 4 5. Okay, that's it. There is no need to name the top or bottom edges both. Okay, so 1, it will come here, 2 and 5, and 3 and 4. Now same as parallel line method, as we have discussed earlier, we will extend this. Then we will start by taking one edge. Let us start from the 1. So this is 1, then 2. The distance, we will measure this distance 1 to 2, put an arc, and then 2. Similarly 2 to 3, the distance will be the same because it's a regular pentagonal prism. 3, 4, then 5, then 5 after 5 again 1. Okay, now what we'll do, we will start projecting all the edges onto this parallel line edge development surface. So this is 1 and one edge is there also, so we will project it to here. Then 2 and 5, so 2 edge is there, 5 is there. Then 3 and 4, so 3 and 4. Similarly bottom is also truncated, then 1, so 1 and 1, then 2 and 5, 2 and 5, and 3 and 4. This one is 3 and this one is 4. So we can find out the intersection points. Similarly top, so now what we have to do is we just have to join these points. So this is the development of this lateral surface, but still one point is missing. What is that? We have not considered this pipe hole. So let us consider it. We can see that the pipe hole is on the surface of 4 to 5. The 4 5 surface is there. We have given that vertical distance where the center of the pipe hole is there. So from here we can measure that up to 32 mm above. So 32 distance we can measure, and we can put a line. Similarly, in 4 to 5 the axis of the hole is given, and we can measure the distance from 4 edge to up to the axis of the hole. Same 4 edge is here, same distance we can measure here, and we can draw a vertical line. Okay, so where the intersection, both lines are intersecting, it is the center of the circle. We have given the diameter of the circle, so considering this as a center, we have given the diameter, we will draw a circle. That's it. Now we have completed the development of this pentagonal duct. Okay, now we will move towards next question. Next question: a regular square prism of 30 mm base edge and 60 mm height rest on its base on HP such that its vertical faces are equally inclined to VP. Okay, we have a square prism, it is resting on its base on HP such that its vertical faces, we have 4 vertical faces of square prism, so all the faces are equally inclined with VP. Then it has an horizontal circular hole of 30 mm diameter drilled centrally through it such that the axis of the hole cuts both the diagonally opposite vertical edges. Okay, so first of all we will draw the top view and front view of this square prism with in the same condition as given by in the question, that its vertical faces are equally inclined. Okay, so we have already done this type of problem in projection of solids. So we know that if it is equally inclined, so the top view of the square prism will come like this, and from the top view we can project the front view. Okay, now it is told that a horizontal circular hole of 30 mm diameter drilled centrally through it. Horizontal means the axis of that hole is horizontal, and at the centrally means if the total height is 60 mm, the center of the hole will be at 30 mm. So this distance is 30 mm. Okay, and the hole is drilled in such a way that it is cutting the diagonally opposite edges. Okay, like here one edge will be there, and similarly here one edge will be there in vertical into the paper, so it is cutting both the edges. Okay, so same as previous, what we will start after naming it. So A, B, C, D. Okay, same here. A, this one is B and D, and this one is C. So now we have to project this hole also. Naming it same as previous one, we will extend these lines. we'll start after taking one edge. Let us take A. So this one is A. Then we know this distance, so it will be the true length. So after measuring this, this is B again. C. D. Then again A. Okay. This we have developed the lateral surface, but still we have not considered the drilled hole. So for developing the drilled hole, what we'll do, we will divide this circle into number of equal parts. Okay, then start naming it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay, now project all the points to top view. So 1, 12 and 2, 11 or 3, 10 and 4, 9 and 5, 8 and 6, and 7. Okay, similarly we have to project on this lateral surface development. Then 12 and 18. Then 9 and 11. And 10. Similarly downwards, 6 and 2, 5 and 3, and 4. Okay, so now we know that the center of this hole is on B edge and D edge. Okay, so B edge is this one and D edge is this one. Center is, we have projected this line, so one center is this and another is this one. Okay, this one and this one. Now what we'll do, we will start measuring the distance. Okay, from A to this much distance, let me call it 1, this 2, this one is 3. Okay, so from A to 1 we can measure distance, this much, and A edge is this one. So by after measuring distance we can project upward, then A to 2, after that A to 3, then B1, fourth point, it will come on edge B. Similarly this 4, then 5, 6, 7. Okay, so after B edge this one is 5, then this distance B to 6 we will measure. From B to 6 we will draw vertical line, then B to 7. So this one is 1, this one 2, so 3, 4, 5, 6 and 7. Okay, so now we have completed almost. What we have to do, we just have to find out the intersection point. How? This one is the one line and this one is the again one line, so this will be the one intersection point, again 2, so 2 is this one, okay, and same 2 and 12 position line is same. Okay, so above one intersection point, same 3, so 3 point this one and 11, both projection lines are the same, so this one will be 3 and this one will be 11, then again 4, same goes with 5, then 6, then 7. So what we have to do, we just have to join these points with the help of French curve. As we have drawn it free-handed, that's why it is not coming like exact ellipse. Okay, so similarly what we have done, firstly we have named the square prism, then we have extended this lateral surface of the prism, then after that for developing this circle, what we have done, we have divided this circle into 12 parts, then from the all parts we have projected all the numbers we have projected on this top view. Similarly we have projected this on the lateral surface. After that, just taking this distance, like from edge A, one point is this much distance, so same distance we can measure and we can put 1. Then again A to 2 distance we can measure and we can put a line number depicting 2. Okay, so after that, just taking the intersection of these two lines, vertical and horizontal lines, we can find out number of points. So, and joining these points with the help of French curve, we can achieve a ellipse. So we can see that this hole is not only on B edge, it is also on D edge. So again, one more ellipse will come this side. Okay, so for that we can take these distance. Here distance, one point is there, this one is there, this one is there. Okay, this one, this one, this one. So this you can complete it later yourself. Okay, so next, now we will consider a question in which we have to develop a cylindrical tube. Okay, so what we'll do, same as previous one, we will extend these lines. Okay, let us consider an edge. See, we know that if the diameter of this cylinder is 40 mm, then the length of this lateral surface will be equal to pi into 40. Okay, because this will be the perimeter of the cylinder. So we can easily calculate pi into 40, and we can measure this 40 pi distance here. So this is the development surface of cylinder, but we can see here that the cylinder is also truncated from the top. Okay, so for developing that, what we'll do, we will again, because cylinder has no edges, so we will, how we will find out the edges. So what we'll do, we will divide this cylinder into number of parts again, same as previous one. Okay, then start naming it 1, 3, 4, 5, 6, 7, 8, 10, 11, 12. Okay, so now we can see that we have divided the perimeter of this cylinder into 12 equal parts. So same you have to do with this. You have to divide this into 12 equal parts. And for dividing this length into 12 equal parts, you can use any method of division of length. Okay, so I will divide it into 12 equal parts. Start naming it. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1. So this portion we have taken extra, so this will not come. Up to this is 1. Okay, now also project these point on front view. So here it will come the 1. Now after projecting 2 and 12, we get a point, then 3 and 11, we will get a point, then 4 and 10, it will intersect here, then 5 and 9, then 6 and 8, and lastly 7. Right? So naming it, start naming it. This will come 2 and 12. First of all, this one is 1, we have already written, then 2 and 12, then this one is 3 and 11, then this one is 4 and 10, this one is 5 and 9, this one 6 and 8, and 7. Okay, so now we have done with naming. Now what we have to do, we have to just project all these points on this lateral development. So one edge is here and one edge is here, so project it on. Similarly 2 and 12, so 2 edges here, 12 edge is here. Three and 11. So 3 edge is here and 11 is here. Then 4 and 10. 5 and 9. 6 and 8. And lastly 7, it will come here. Okay, so now we can find out the intersection points. 1 and 1, this one and this one. Again, second one is 2 and 12, so 2 is this and 12 is this. Third one is 3 and 11, so 3 is this one and 11 is this one. Then 4 and 10, then 5 and 9. After that 6 and 8. After that 7. So we just join these number of points with the help of French curve. And this is the development of this truncated cylinder. Okay, so once again we'll go through it. What we have done, we have started by extending this edge, then dividing the circle or top view circle into 12 equal parts, then naming it and project it into the front view. Then from the front view we will get a number of points. These points we will project on this lateral surface and we will find out the intersection points. Then by joining the intersection points we will get the development of that truncated cylinder. Completed the development of this cylinder. Now we will move to next question. Here the one cylinder is given. It has been truncated from the bottom into the circular shape and from the top into this given shape. Okay, I would suggest you to try to do it yourself, and I will put the solution of this question into the comment section or into the group. Okay, so that's it for the today's lecture.